Hi, this is Loki with Blue Collar Prepping. After last week's video, Erin had some more questions about what certain electrical terms I was using meant, and I decided, after talking to her, that probably needed to do a Eli 5 of the four basic electrical terms. So, we'll start with the volt. And voltage, electricity in your house is measured generally 120 volts. Your big appliances are 240 volts. In a big industrial facility, you'll see 480 volts and sometimes larger than that. Well, voltage is a measure, quite simply, of potential energy difference. So the easiest way to demonstrate that, a battery has energy stored in it. It has potential. Standard AA battery has 1.5 volts of potential in that battery. And that energy isn't doing anything until you put it to use. And in a battery, where it's a storage medium, you put it to use and it goes away, it gets used up. In your house, because you're constantly having energy generated from your power plant, it doesn't get used up, but it does flow through your circuit and then back to a ground system and is effectively used up. So there's, in my house, on most of my circuits, 120 volts of difference between the black wire and the white wire in my on receptacle, which is the hot and the neutral. So it's the amount of energy in that circuit being run. Related to that is the amp, or ampere. And that is a measure of current flow. Because what actually flows through the wire to make electricity move is the electrons. Copper electron moves from here to here to here to here to here as energy transfers them along. In a direct current circuit, battery power, they actually move in a line. In an alternating circuit, like in your house, AC power, they kind of transfer back and forth. It's kind of a handoff. And the specifics of what a single amp is, that gets into some pretty deep dive, but it is the flow of electrons carrying energy through the wire. And that's how they measure those. Now, there's also what they call ohms. And an ohm is a measure of resistance. Everything is somewhat resistant to electrical current. Copper is minimally resistant. Gold is actually a little better. That's why certain electronics have gold-plated terminals. Aluminum is a decent conductor, but not a great one. But it's light, so we use it in really big wires. Steel is an okay conductor. Rubber is a terrible conductor. So we would say that rubber, or plastic, has a much higher resistance than copper, aluminum, gold, all your metals. Some of those resistances are so high that normal testing equipment can't measure it. It just says over limit. Copper has a set resistance that we know of for different diameters and that. And so that's all measured in ohms. The higher the ohms, the more resistant a material is to transmitting electricity through. And then the fourth big term that you'll encounter is the watt. Now, 1 watt is 1 amp at 1 volt. So, a 100-watt incandescent light bulb that has been around since Thomas Edison got real wild with the tungsten filament is, so 100 amps, or 100 watts, 120 volts, that lamp pulls slightly less than 1 amp. If I had that same thing on a 240 volt circuit for whatever, it would pull half of that amperage. It's called Ohm's law. All four of these things are interconnected, and it's all deep electrician math, but know that a watt is 1 amp at 1 volt. So a 1200 watt microwave pulls 10 amps on a circuit. A circuit breaker, say if you have a 15 amp circuit breaker, it'll hold, but you can't put much else on. In my house, if I have my TV, my microwave, and anything else in the kitchen on, that's too much wattage. It pulls too many amps and trips my circuit breaker. So you have to pay attention to the wattage of appliances when you're running them together. And all of it is interconnected, but they're all fairly basic terms of how they interact. And if you have any questions, please ask in the Facebook group, on the blog itself, shoot me a message in Facebook. I'm happy to answer it and break it down further if we need to. Otherwise, thank you much.